So hi, everyone. If you're just tuning in, my name is Marco Abela. I'm joined by my colleague, Chuck Farah, and we are part of the storage product management within Dell Technologies, and we're here to talk about PowerStore data mobility. So what we're going to be covering as part of this session is first protection and reuse capabilities within PowerStore, taking a look at PowerStore's snapshot and clone capabilities. Then we're going to talk about protection policies and how they get applied to PowerStore objects and how that ties in with asynchronous replication capabilities within PowerStore. And then Chuck is going to cover PowerStore's Metronode offering the highest levels of availability with active Metro, followed by the use cases. So PowerStore protects data locally and remotely, starting with async replication using efficient snapshots, which we will cover in the next slides. Both local and remote protection are applied to PowerStore objects via scheduled protection policies from the PowerStore manager, making it very easy to enable, check compliance, and recover if needed. So starting with local protection, a local snapshot protects the storage objects such as a volume with immutable efficient snapshots that cannot be mounted, but rather only be used for recovery. The flexibility of efficient snapshots is such that they can, however, be repurposed by creating an efficient clone from the snap to be mounted and used, for example, for use cases such as test dev and analytics. From a remote protection standpoint, snapshots are used to replicate data from a source site to a remote site with, again, different point in times available for recovery, with the point in times being the different snapshots. As you can see, local and remote protection is enabled via our efficient snapshot implementation. Defining the schedules for PowerStore object protection is done via protection policy, in which a snapshot rule and or a replication rule is defined and applied to a PowerStore object based on a user-defined RPO or schedule. For local protection, a user defines the days to run, the frequency or time, and also a retention policy saying how many of those they want to keep before they start getting deleted. While for replication rules, a user defines a destination, an RPO, and the alert threshold. The combination of these rules is what makes up a protection policy, which again can be either local protection, remote protection, or a combination of both. Once a protection policy is created, assigning it to a PowerStore object is super simple. You just select the volume or the object that you want to protect, click protect, and choose which of the protection policies to assign. As soon as the protection policy is assigned, the system will automatically configure and begin the local protection schedule or the replication, again, making it very, very simple to use. Now let's talk about remote replication. So as I mentioned before, PowerStore replication is very easy to use with policy-based provisioning. It supports a low RPO with instant recovery, and it's scalable. As a user establishes a WAN link between a source PowerStore and a destination PowerStore, and replication begins via snapshots based on the user selected RPO. To get the source and destination in sync, an initial snapshot is created and replicated to the remote site. After the initial sync happens, a snapshot is taken based on the RPO and is compared to the last snapshot. Snapshot diff is calculated so that only changed data blocks are replicated, making the replication very, very efficient. All snapshots are available for recovery, so that a user can pick the latest snapshot or a specific point in time, again, based on the flexibility of our snapshot implementation. Next, I'm going to turn it over to
Marco,
Chuck.
Before you go, this is Ray. With all the data mobility that PowerStore has within a cluster, do the snapshots move with the data as a volume, let's say, moves from one cluster node appliance to another cluster node appliance?
So so here we're talking about two different clusters. You're saying within a cluster, if I move a particular
Data mobility,
object.
right? A volume can move from one node to another based on, recommendations and that sort of thing.
So I believe so. Abhishek, do you know the answer to that question?
So if you move a volume, then we call it a volume family. So the snapshots and clones move along with it. Yes.
I got you. All right.
Because remember, again, we don't want the interconnect to be in the data path. So if the data
and the replication is going to replicate all snapshots that occur, or just there's a schedule for local snapshots. I guess there's another schedule for remote replication. So you're only replicating when the remote replication kicks off, I guess.
Exactly. And then based on that retention policy, it then also deletes the ones that you say you don't need any longer.
I got you. All right, thanks.
I have a question, please. Can you go back?
Yeah. Hi, Kirsten.
Yeah, hey. You said you can do instant recovery, but when I understood it right, it's not that I can switch my production side to the disaster recovery side. So I'm still working on the production side. When it crashes, I have to rebuild the machine and then putting all the data from the disaster recovery side back to the then new production side.
Yeah, so from the actual like host application site, you're gonna have to do some type of failover, right? But what I mean by this is from the actual, if this volume right here that's on the DR side, right? When you say I want to now start my failover and I want to pick this particular point in time, this host that exists here, if it's already attached to this volume, you don't have to do a new SCSI rescan to identify this volume. It keeps the same the same SCSI volume characteristics so that you don't have to do a rescan or anything like that. That happens automatically and instantly because it's just a metadata operation of selecting which of the snapshots or the point in times to select as part of the recovery.
Okay, but I cannot work on the disaster recovery side. I have to, when it crashes, I have to wait until the data is re-replicated.
Well, again, it depends what point in time you're selecting as part of your the recovery process, and then the how long it takes is based on your application mobility from the actual host perspective.
Okay, I think I got it. What happens when I was hit by a ransomware attack and all the data are
Great question. Yeah, great question. So, right, that's the flexibility of selecting a specific point in time. Right. So what you have with other solutions is that in a lot of cases from a failover perspective, they just select the latest point in time. What this instead gives you is a catalog, let's say, of different point in time so that if you know your ransomware attack happened at midnight, right, and that all volumes after midnight are going to be encrypted or part of the attack, I know that if instead I select a previous point in time from one before midnight, I can select that as my recovery. And then your data will be good.
Everything will be lost after midnight then. So there's no further protection to keep the data uncompromised.
Well, we have, so as part of being a portfolio company, right, within the Dell Technologies umbrella of our data protection division, we have integration with the Power Protect family and all of those capabilities. All the capabilities that those solutions have in terms of cyber recovery that PowerStore integrates with as well.
And are those snapshots immutable?
So these snapshots right here, these are non-mountable snapshots. So that what we refer to in snapshot from a PowerStore perspective is they are a reference point for recovery. If a user instead, which I covered in the slide before, if a user instead wants to mount a snapshot, they have to create a clone of these snapshots, which again are very inefficient. It's just a matter of the metadata pointers, which then get mounted and used. But these snapshots here are immutable in that they cannot be mounted and data cannot be changed from them.
So hi, everybody. My name is Chuck Farah. I am the vPlex Metronode product manager. I've been in the industry for a long time. I started out at IBM and then But what I'm going to focus on now is a new product known as Metronode. PowerStore Metronode is kind of the tagline for it. It was introduced in January. This is a new feature that provides that active-active real-time replication. And I think you were talking about it a little bit, Kirsten. Hopefully this answers that question somewhat. But this gives you true active-active replication between synchronous distances. It also provides for flexibility by using, giving it the capability to have heterogeneous arrays attached to it. And then all of this is done with the ability to do this non-disruptively from a application perspective. Built on Dell rack servers, it takes up a little bit of space, a 2U worth of space. Also takes advantage of some very mature server software technology to provide some other features, not only just active-active replication, but multiple platform flexibility as well as workload mobility, which is what we're going to focus on here in a couple of minutes, without application disruption. So since this appliance does not really drain compute resources, it's not built into the array itself, it's outside of that, we feel like this is an advantage in this space. It does not require additional cost, complexity for host software, or require any capacity on the storage array. So I'm going to focus a little
Chuck,
bit on.
Would this be considered a stretch cluster, or is this just synchronous replication through another appliance kind of thing?
It's through another cluster or appliance, if you want to look at it that way, and it is within synchronous distance. So this is all, everything's in sync, constant write synchronization.
So is it, I guess I didn't hear what you just said, Chuck. Is it bidirectionally replicated, or is it, can I access the data on both sides of this replication?
Yes, you can. This is bidirectional. This is what we consider active-active. I don't know if you kind of are familiar with the Metro concept.
Yeah.
Basically, this is the Metro concept where you have active-active and automation. The automation part is provided for by a witness. So if site has lost connection to the other site, the witness.
So, I mean, synchronous replication implies that the data is not actually acknowledged as being written until both sides have access to have the data.
That's correct. Yeah, so both sides have access.
And so that's happening here. You're actually not acknowledging the write to the PowerStore until the data is actually located at the other PowerStore location?
From the Metronode perspective. So it actually does the acknowledgement. So it'll write the data to the remote PowerStore, if you will. And once that data is written there, it writes to its local, and then that is acknowledged to the host.
So the appliance then is in the data path?
That's correct. It is in the data path. It's a virtualization layer in the data path.
All right. Thanks.
Yeah. Very good question. All right. So for the use cases, we have seen this technology used in several different types of use cases. I'm going to focus on these three. Disaster avoidance. This is probably your typical thing where you can predict an event, for instance, a flood or, maybe even a fire, as you know, today that's going to be more important. Hurricanes, of course, give you a little time. So instead of doing a complete failover to another site, sometimes the decision is, hey, let's just move some of these applications over to that site and, make that decision as we need to later. So this would be like a preemptive type of disaster avoidance, just using data mobility as a mechanism to move specific applications, more surgical. Planned upgrades is another great use case. Most arrays have a certain criteria before you can do an upgrade of the firmware within the array. For instance, CPU needs to be below 50% or 75%, whatever the number is. And you can move those busy LUNs over to another array to allow for that NDU to occur without impact or risk. And then we also see kind of similar kind of activity with the movement of facilities. You might bring up a brand new data center within synchronous distance. And when you bring that up, you don't want to just fail everything over right away. You might want to do some testing, moving some of the applications over that may be less impactful. And then as you get more confidence with the network setup and the infrastructure with that new data center, move everything over. And you commit those with these mobility jobs. keeping in mind, since this is an active-active infrastructure and architecture, the application continues to use the same data, though the data has been moved to a different storage array. That's the virtualization aspect. So I'm going to try to show, using the core infrastructure, how workload mobility fits into this model. It is built on this whole concept of active-active synchronous replication. I'm showing site-to-site here. That can also occur within a single location. So you could have multiple arrays, and they're getting the same kind of concept of synchronous replication. But with the site-to-site concept here, we have it right in the middle of the data path, as you mentioned. The Metronode is there, right below the server clusters. And in this case, we're attached to a PowerStore. So we could have one array here. We could have multiple arrays here. And then on site B, the same kind of configuration. I'm just doing this for simplicity. It can be a lot more complex than this, and you can add more data.
So Chuck, this only applies to PowerStore T, not PowerStore X. So Apson couldn't use this facility, or?
Yes, Metronode does support the fiber channel connectivity for PowerStore. So Apson is supported with fiber channel, and therefore Metronode is supported. This distance between these two sites is not really as relevant for distance in feet or meters. It's more in the latency. So what we ask is most applications are tolerant of a 10 millisecond round trip time. So if you're within that tolerance range, this synchronous replication can occur, and you can have your data center that distance away. So I'm just showing how the infrastructure works. So how does the non-disruptive move of data occur? Well, I'm going to give you an example. On the left, we have two red volumes. I'm just indicating that we want to move those for whatever reason. It could be one of those use cases we mentioned earlier, or even if you have a performance impact on site A, for instance, and you need to move some resources off that site to a different data center even. This could be done locally, but we're going to show an example. We're going to move one of these volumes from this data center, which is, we're having performance impacts or even capacity. And when it does that, there's no impact to those applications. And then it'll get to, does that light gray there just means that everything's copacetic. And that gives us that capability to do that without having a disruption. Now, just to kind of give you an idea what's going on behind the scenes, we actually do not change the volume identities during this entire move. So we just keep those access points to the host. So as far as the application knows, nothing's going on. This is all done behind the Metronode clusters. Now, with Metronode, we can also add different types of storage arrays. They don't have to be homogeneous. We can have actually Unity XT is currently supported. So we can add a Unity XT, and there'll be others in the future. They go through our qualification labs. But with Unity XT over here in Site B, for instance, I could do a local migration. So here I'm doing local data movement. Now, keep in mind, this is all 100% reversible. If I need to move back to Site A or move any combination of those volumes to Site A or Site B, and I can even have multiple arrays on Site A as well, I can do that with this mobility technology. And this is all without...
And Chuck, it supports the clustering capability of the PowerStore on both locations?
Yes.
Or they can be different size clusters at both locations?
That's right. You could have a 4 appliance cluster on one side and a 2 or 1 on the other side, and we can do that same data mobility. It does it at the volume level, and since we are abstracting that layer, it doesn't really matter what's really behind all those arrays.
So when you say it does it at the volume level, it's the replication capability is and the Metronode capability is defined at a volume level?
Correct. Yeah. So
it's not like everything on the PowerStore has to be replicated.
Exactly. Very good point. Yeah, you can have different parts of the PowerStore that do not use Metronode, and that can just be local to whatever servers you have attached, as well as Apson for those that are got mixed clusters in the environment.
And the applications themselves, if you're moving this from one site to another, the applications would be cross-site as well, I guess, right?
Right. That's correct. The application with the server cluster would span those sites and
I
allow you
got
to
you.
have that data motion. And
All right.
you know, some of that, maybe your question might be a little bit about, you know, what's the difference between this and, you know, vMotion or, you know, live migrate. And really where it comes into play is that instead of using those host cycles to do those type of operations, we're offloading that and making it a little bit more enterprise, if you will, giving you the capability to scale quite a bit more VMs, quite a bit more, and especially if you're in an emergency mode, you need to move quickly. vMotion may not be fast enough or nearly scalable enough. So that's kind of one of the benefits. Also, there's a political benefit. Sometimes the storage admin wants to have control over the resources and not just release that to the hypervisor admins, if you will. So there has been some, I actually have Lakesh and Anchor on the line, and they can give you some testimony on how some of those customers, really push back and wait for schedules that don't accommodate the real business needs.
All right, thanks.
Sure.
Question is more likely than an evolution of the SC live volume. Are you planning to support some kind of migration? Because, for example, in Europe, there are a lot of customers that are actually using a compellent with live volume, and they are looking on how migrate to other solution, or in this case, this solution. You have a good migration tool for traditional configuration with a different product that can migrate to PowerStore, but in this case is a little more complex, but with this virtualization layer, when you put those two appliances, can be easy migrate.
Right. In fact, this is used quite often for what we call tech refreshes. So you have Metronode in the front, and you attach any array behind it. It can be a third-party array, and you can actually do a complete migration from that third-party array to Dell EMC, hopefully, and that does apply to compellent SC live volume automatic failover as well.
Okay, and it's already validated for VMware stretched cluster or Metro cluster.
Well, funny you should ask that. We just now released Witness, and literally last week, which gives us that capability to be, to accommodate the criteria for that Metro certification. So that should come out in a couple of weeks, maybe a month. I shouldn't really promise anything, but it's at VMware's discretion.
Okay, thank you.
Sure. Are there any other questions? That's really the quick summary of data mobility. I think you kind of got from Marco some of the native features with the, repurposing the data. We're just showing you another layer here to give you real-time, high availability, as well as automatic failover, as well as using that technology to do mobility to kind of balance and consolidate your infrastructure. Of course, we have the usual links to give you some more information. There is, of course, the landing page for PowerStore documentation. And then we have some Metronode videos, PowerStore Metronode videos, spec sheets, solution briefs, and some other documentation.